Hello, welcome back to our revision series, a question under radioactivity. So this a question under radioactivity, and we must be in a position to understand what radioactivity is, then look at the radioactive substances and look at the radioactive decay, and again how to calculate what we call half-life. So this is one of the approaches of calculating half-life from this question. But what is this that we call half-life? Half-life simple means the time taken for half of the number of radioactive nuclei present to decay, or half-life is the average time taken for the activity to decrease to half of the initial value. Now, there are three methods of calculating half-life. One of the methods that we are introduced to is the linear method. And method 2 is graphical method, and 3 is the formula method. These are the three methods for determining the half-life. So in this question, they're talking about graphical method. So this is a graphical method. So under graphical method, you don't need to struggle so much. Just look at the initial amount, which is 400. It's supposed to decay by a half, or its value to decrease to half of the initial amount. So the initial amount is 400. So 400 decreases to a half. So 400 decreases to a half. That will give you 200. So come to your y-axis where you have the grams. So half of 400 is 200. So using a ruler at 200, now you draw a straight line to meet your curve, then draw again to meet the x-axis. So at that value, at the x-axis, this value will now give you what we call half-life. Again, interpret your scale. Now, from 0 to 8, those are 5 divisions. So 0 to 8, we have 5 divisions, meaning that each division, for our case, each division is equal to 8 multiplied by 1 divided by 5, which gives you 1.6 days. But how many divisions do we have? These are 5, 6, 7, 8, 9. So those are 9 divisions. Therefore, our half-life will be given as 1.6 multiplied by 9. This gives you the number of days. Therefore, when you multiply, that gives you 54. So that is 9 plus 5, that gives you 14. So 14.4 days as our half-life. Thank you.